Hello everyone. Today I show you some 1D CA analysis problem. Maybe 1D, for example, beam analysis can be conducted by my practicing uh, method. The target is to learning the program through beam element by CA analysis. As you know, CATIA program have a CA analysis module. Therefore, if the structure element are too simple, then we can simulate or analyze the structure problem by CATIA program also. Without any ANSYS Abacus program, it is not needed. If that is very simple, then we can just know the analysis result by this simple simulation. Therefore, we should learn about it to making or to draw some or making some design of some product. In that time, the CATIA program CA module is very useful for you. Therefore, in this case, I will show you some problem and I will talk about it and I will teach you for easily manipulating this kind of module by myself. Therefore, first step is that we should prepare to use analysis program for beam analysis. First of all, it is recommended to set the settings necessary for analysis because it is easy for analysis work if they are set at once. Select the full down menu like this and enter to the tools, options, analysis and simulation, then generative tab and click the following two values. Maybe click show parameters and show relations should be clicked in this time. Therefore, I will show you by practice myself for you. First, we should do tools, go to the tools and options and analysis and simulation part. They are placed in this part, and if you click analysis and simulation menu, then please click the general tab and click uh, general tab and click the following two values. Specification 3, show parameters and show relations should be clicked, should be checked is necessary before analysis and before preparation. Then if you click OK, then another step can be ready to go on. Therefore, next step, we should do performing the modeling first. One the problem is very simple like this. As you know, line or curve or some things is 1D problem. Therefore, among the one-dimensional element, the beam is an element that supports tensile compression. Tensile is the direction is like this. Compression is maybe this direction. In case of tensile, maybe the some part should be needed to tensile direction. I will show you this is tensile direction like this. If that is fixed or fixed point is here, then this is tensile direction, and also in compression case, compression is applied to this direction to here. This is a tensile and this is a compressive direction to here, and it can be compressive by this operation, maybe, and may also this is compression. I will show you. I will uh, talk you, and another one is this direction is tensile direction in case of beam 1D problem. More. And sometimes the cross-section area bending load can be applied here. Here is if the some arrow part or some load should be applied to this direction. This is a bending direction. If this is applied to this beam element, the deflection shape can be like this. This is the deflection shape after bending problem. Therefore, I will write you this is bending case. Okay, maybe some part should be changed from black to blue is needed for differentiating the between explaining sentence and some direction named sentence, and basically requires physical properties. If this beam element have still that if bending is direction is like here, the deflection is here. However, if this material is aluminum or magnesium, the deflection is more severe better than steel, as you guess. Therefore, physical properties is very important for analyzing the CA analysis. And next, cross-section area is also important. If this beam cross section or beam profile is rectangle, triangle, circle, star shape. In that case, the bending, if bending load is applied to the beam, then the deflection or deformation mode or degree can be differentiated depending on the material, or depending on the cross-section area shape. Therefore, I will say about it, about cross-section area in later, and that is very important. The two properties very important. The first is the physical properties, and second one is the cross-sectional property. And the second moment of cross-section, it is also important. To perform modeling before analysis, first enter the generative shape design workbench and create a 200 millimeter long straight line from the origin in the y direction as follows. I will show you in the CATIA program about it for easy understanding. Start maybe analysis and simulation part, and generative shape design. Generative shape design is placed in shape directory, and in this part we should do maybe we should making some part of following as XY plane like this, and enter to the sketch workbench in here. And also in this time we should draw a line like this, and the draw length should be 200 millimeter in this time. Yes, and Line line is made from line definition part. Therefore, I will exit to here, and in this part, I will generate 000 point in this origin point, and please select line, and please change the point line type to point direction like this, and point should be started from this one, and direction should be changed to y direction, y component. And the end start is 0 millimeter, and end is 200 millimeter like this. Then the line can be made from this operation law. Yes, and the next one is I previously said you about that material property and physical property. Material property is dependent on physical property. Therefore, material properties determination is also very important. In this case, click the apply material button. Button shape is like this, and click metal tab, and among various menus in the default material catalog dialog, and select steel. The OK button is not yet active in selecting this. However, if we click part, then this is activated in this case. Therefore, material is set in part body as shown in the following figure. Following figure is like this: part body and material is appeared generated in this specification tree. Therefore, I will show you the exact meaning, exact what they are meaning. This is material property, apply material command icon, and in this case, metal fabric. There are too many materials. First one is construction element, bathroom floor, concrete, grate, glass, gravel, old tile, low skid, and next one is the fabric. Fabric is brown fiber, brown lead, canvas. The third one is metal. Among various metals, aluminum, brass, bronze, brushed metals, chroma, copper, gold, iron, lead. This is a PB. In this case, we should click steel. However, if we click steel, select steel, the activation button is not activated. OK button is not activated. Therefore, in this case, please click part 1. If we click part 1, then OK or apply material button is activated, and please click apply material, then steel material can be generated in the part body tree like this. In this case, please click OK. We can see the steel material property to find out in the part 1. If we click part 1 and the mouse button number 3, clicking the mouse button number 3 and select the properties, and in case of select mass, then mechanical, mass, graphic, product, cancel. I'm sorry, please click steel part, and clicking the steel material will by mouse button number 3, and in this case, please click analysis. Therefore, the Young's modulus of steel, as you know, is 200 gigapascal. This is Newton per meter scale. If it is translated to the gigapascal, then 200 gigapascal or 200,000 megapascal is the Young's modulus of steel, as you know. And in case of Poisson ratio is the ratio between this direction and this direction. With this direction, longitudinal direction versus her with this direction ratio is named to, and that is a relative value to positive value by relative applying relative number. Therefore, still Poisson ratio is 0.266 in CATIA program. That is promised in CATIA CA program, and density, as you know, steel density is 7.86 gram per cubic centimeter. Therefore, if it is translated to kilogram per meter scale, then 7,860 kilogram per cubic meter is the density of the steel. However, if it is changed to this is thermal expansion and the yield strength is 250 megapascal. Therefore, in this case, if we change the, please delete it, and if we click apply material first, once again, and if we click aluminum in the material and apply material, then you can find out mouse numbers, clicking mouse number 3, and properties of the aluminum is different. Maybe the mass is Young's modulus is 70 gigapascal, very lower than steel. Maybe 1 per 33% of the steel, and the Poisson ratio is somewhat large, and the density is 33% of the steel. Maybe in case of steel, 7,860 kilogram per square meter. However, in aluminum, very lower, 2,710 kilogram per square meter. Therefore, the aluminum material is a very light material, better than steel, as you guess. Therefore, in the document sheet, we should return it to the steel once again, and we should have analysis in this part. And we will go on to have a lecture like this. And in this case also, the part where this material still is applied in this, and change of the view mode is possible with the following icon. And if you select the view mode with the material properties assigned, the color of the part body changes. There are a total of 7 view modes: shading, shading with edge, shading with the edge without smoothing edge, shading with the edge without hidden edge, shading with the material, wireframe, customize with the parameters. If you try it yourself, you can easily see the difference. Maybe in this case, please select this one, and maybe first one. Shading with material is this button. This button is changed with some part. Maybe some other part. However, this is only one element. The shade cannot be differentiated each other. However, in case of 2D element or another element in the future class, I will show the exact meaning of the shading method differentiation. Next, material property, we can the specific tree to check the steel property as I previously showed you, and in the screen the tree, double click the steel as shown in the figure. Double click also activated in the material. Please by mouse button number 1, double click, then property can be appeared, and next analysis you can find out the steel material property of the steel like this. And if you understand about it well, then I will explain the next page. CA analysis is somewhat complex because there are too many steps to know. First step is to pre-processing step and running the GSA workbench, run the generative structure analysis workbench as shown in the following figure. In the generative structure workbench, a mesh is automatically defined for the shape and the settings can be changed. In the advanced meshing tools is AMT tools workbench, you can specify meshes one by one and create meshes for each desired shape to complete modeling. If we select generative structure analysis from the analysis and simulation menu, window as follows: specification A, static case, and specification 3. Static case is created in the tree. I will show you later, and at this time select static analysis and click the OK button. Static and click OK. Next step, we should go to the generative structure analysis workbench. Therefore, please click Start first, and the generative is analysis and simulation, and generative structure analysis workbench is placed in here, and please click generative structure analysis like this, and if you enter to this workbench, and you can find, if you click plus button or plus button like this, and sometimes I still part, find an element, model, properties, material, and the next one is in this part. Okay, I'll find it. I will find out these windows. In this window is hidden to my image photos. Therefore, this is a new analysis case because I will cancel, and if you enter to the generative analysis and simulation and generative structure analysis once again. Therefore, this view analysis case should be activated by this operation, and in this case, you select the static analysis button in the first place in first menu. Therefore, please click OK button. Then static case is appeared generated in the tree menu like this. Therefore, if you click OK button, then this analysis case is only static case. There are too many cases, steady state case, nonlinear static case, any other too many cases. However, in CATIA CA program, maybe most of the C analysis should be the analysis of static case. Therefore, static analysis is almost default menu. Therefore, if you enter to the generative structure analysis workbench, then you automatically select the static case in the new analysis type, and in this case there are no problem if you select the static analysis case like me. Okay, the time is end time is reached in this time. Therefore, see you next time, and thank you for watching. Goodbye. I will show you the next step, next class. I will show you and finish this analysis type in later time. Goodbye.